where the k starts. This is the kth term. I need to check if this goes to 0. Now when k goes to infinity, both numerator and denominator go to infinity, so we can use L'Hopital's rule. Which actually is done very simple. K approaches infinity. Derivative of k is 1. Derivative of 2k plus 1 is 2. So this is 1/2. Well, 1/2 is not 0. Therefore, the answer is what? Divergent. Okay? All right, let's look at perhaps another one. About, yes? Oh, yes, you see. Any question? Okay. All right, let's look at maybe another one. Yeah?
Before when you said if the limit is equal to 50 and 0 is inconclusive, why?
Before, which page?
That page.
This page?
Why is it inconclusive if it is equal to 0 in that box?
Why is that? Why is that?
Inconclusive.
He wants to know why it's inconclusive.
Why is that? Limit? Which line you have question? This one?
Yeah.
Here, yeah. So this thing says if the limit of a is not 0, then this is divergent. But then the question is that if this is equal to 0, can we give a conclusion? The answer is no, you cannot do a conclusion. So if this is equal to 0, then it is inconclusive. I hope you can read this handwriting. Inconclusive. Inconclusive, whether the series, whether this series okay AN is convergent or divergent. We cannot conclude anything. That's what this means. Okay. If it's not 0, if the limit is not 0, it is divergent. But if the limit is 0, we don't know. That's the point.
Saying we just can't start with that.
And so say it again.
Are you saying we cannot start with?
Right, we cannot do. If this is 0, you cannot say whether it's divergent or convergent. Okay. So that's why I have this word inconclusive. So we don't know. But what this means is that you have to use different method. You cannot use this method. Yeah. What this inconclusive means, you have to use different method. Okay. In this way, you have to use. If this equal to 0, you have to use a different method to decide whether it's convergent or divergent. Okay. Right? Okay. So now when we apply this theorem into number 9, you see, this is my AK, right? And the AK, limit of AK, well, it's 1/2, which is not 0. So I know that this is divergent. All right? Does it so far make sense? So, for example, if the weather is good, I'm going to go to park. Okay? But what if weather is not good? It is inconclusive. I may go to park if I have umbrella, okay, or I may stay at home if I don't have umbrella. So it's inconclusive. Same thing. Logic. Okay. All right. Let's look at yes.
I was just wondering, like, what's the difference between like the problem we're doing here and the problem we did is like 8.2? Because
The problem 8.2.
I think it was like series because we would take the limit.
This is 8.4, right?
Yeah, but like for here, if you get something other than 0, then it means that it's divergent.
Oh, 8.2 is sequence.
Is that
Sequence is just Okay, this is a good question. 8.2, section 8.2. Now this is a good question. That's right. Okay, section 8.2 is about sequence. Now what is a sequence? Sequence is a list of numbers, A1, A2, A3, a list of numbers. Just a list of numbers. But 8.4 is series. Series more than this is the sum of this. So those two are different. Okay. Sequence is a list of numbers, like 1, 2, 3, 4, 5, or 1 half, 1/3, 1/4, so on. But the series is that you add this up. You add all this up. So they are different. Yes?
Okay, so you said that it's divergent because it starts at 0. Is that right? For the
Number 9?
Yeah.
Number 9 is that this series is divergent because the nth term or the kth term is not equal to 0.
Why does it need to equal 0?
Why is that it's not equal to 0?
Why does it need to be?
Oh, because we have this divergence test. If the nth term doesn't go to 0, kth term doesn't go to 0, then this is divergent. We have this test, divergence test. Okay? It's on page 627, theory 8.8. This is, we have this divergence test. So if a series, if this series is convergent, it is necessary that limit of kth term has to be 0. All right? Yeah, it's very important to distinguish the difference between sequence and series. Sequence is just a list of numbers, A1, A2, A3, A4, blah, blah, blah. Series is really, you add them up. So this could be 1, 1/2, 1/3, 1/4, but this one would be 1 plus 1/2 plus 1/3 plus 1/4. So they are different. Okay. This is really different. This is adding numbers. This is a list of numbers. Yeah. I told this course many times that I know that sometimes people have problem with this and they want to. It's important to know the difference between these two, sequence and series. All right. Well, you can ask questions, okay? Because I'm sure we are on the track. I mean, I'm sure I can finish what I intend to do for this course. So just ask any question you want, okay? All right. So how about let's look at these numbers for 17. So this series.
Professor,
Yes.
can you do another one from that group of questions from 8 to 16?
Yeah, 17 is that question, that group, right? That group is 9 to 18. 19 to 18, 17 is less than 18. Yeah. Okay. So 17 is summation k to 1 over k. Okay. K from 1 to infinity. Okay. Yeah. So how to see whether this is convergent or not? So of course they want us to determine, they want us to use divergence test to determine whether it is convergent or inconclusive. I mean, whether it's divergent or inconclusive. So let me just repeat again this divergence test. What is divergence test? So, given a series, okay, a series. Okay. This series, so if So 1. If the limit of a sub k when k equal to infinity is not equal to 0, then this series is divergent. Now, 2, what if this limit is 0? Well, if this is, then it is inconclusive. Okay, you cannot say anything whether it is convergent or divergent. And if you want to show convergence and divergence, you need to use another method. So in this case, we have to use another method to determine whether it is convergent, whether it is convergent or divergent. Okay, so this is the spirit of the divergence test. All right, so now we look at this number 17. See if we can get any conclusion. Okay. So before I go on, let me line up those page number. 9. This must be 10. This must be 11. Okay. So I'm looking at this problem. Okay. So 17. This problem. Okay. All right. The AK, the k's term is what? K to the 1 over k. And then I'm looking for this limit. Okay, how do we do the limit of this? K to the 1 over k, with k go to infinity? Well, this kind of problem, it turns out you have to use the natural logarithm, that kind of things, or exponential logarithm. So we are using this, which we talked about many, many times. A to the b is e to the b times natural log of a. This is this one. Okay? So this is equal to limit k go to infinity e to the 1 over k natural log of k. I follow this. E to the b, yeah, b, natural log of a, k. So this equals limit k goes to infinity e natural log of k over k. So this, I can bring a limit to here. When k goes to infinity, natural log of k goes to infinity, so is k. So both go to infinity, and this we can certainly use L'Hopital's law. So this is same as limit derivative of natural log of k is 1 over k. Derivative of k is 1. So this is really e to the limit k goes to infinity 1 over k, because 1 over k divided by 1 is 1 over k. When k goes to infinity, 1 divided by infinity, that's 0.